Very pleasant good morning, my dear students. Today let us discuss some problems on DFT by using DIT-FFT algorithm. Initially, let us take problem find DFT the given sequence x of n is equal 1, 2 by using DIT-FFT algorithm. DIT-FFT algorithm. As we have discussed in previous lecture, by using a DIT-FFT algorithm, we should use 10 procedural steps. Okay, by using of these or those 10 procedural steps, let us do the solution for the given problem. Solution. Given data. What is given? X of n is equal 1, 2. But we are going to find out capital X or small k. Okay, now let us use those 10 procedural steps. Step 1. What is that step 1? The number of input samples. Number of input samples. N is equal to 4m from which we are going to find out m. Okay, so from the given data, x of n is 1, 2. Here x of 0th position, here x of 1th position. Okay, so capital N value is 2 power m, from which m is equal to 1. This one is step 1. Next, coming to step 2. Step 2. In the step 2, we are going to use a step 1. That is, in step 1, we got number of samples. So, we are going to use in the step 2. What is the step 2? In the step 2, input sequence, bit reversal. So we are going to take input sequence in bit reversal. Input sequence through bit reversal. So let us write down the input sequence x of n. 1, 2. It is x of 0. It is x of 1. So whatever in the bracket, that is index. First of all, let us write down the index and binary representation of that index. Binary representation. So here the index 0 and 1, and whatever binary representation here, how many number of samples? Only one sample, that is we are going to use only one bit. So 0, and here also 0, whose bit reversal also same. Why? Because there is only one binary digit. So for one binary digit, whose bit reversal also same bit reversal 0 and 1, and here index after bit reversal. After bit reversal, index after bit reversal, that is again 0 and 1. Now step 3. What is step 3? Number of stages in a butterfly. Number of stages in a butterfly. Butterfly diagram. What is the formula to find the number of stages? We know that from the step 1, what we know, n is equal log m base 2, from which okay, what we know that here n is equal to power m. From which m is equal log n base 2. What we know that log 2 base 2, which is equal to 1. That is number of stages. Number of stages. One stage. Next, step 4. What is step 4? As per the step 4 of DIT-FFT algorithm or radix to FFT algorithm, that is the number of butterflies for in each stage. The number of butterflies in each stage. For the given problem, how many number of stages in a butterfly? Only one stage. Okay. So the number of butterflies in each stage is The formula to find out the number of butterflies in each stage is n by 2. We know that the value of n 2 by 2, that is only one butterfly. Next, step 5. Here the step 5 is the input and output butterflies are separated. Input or output stage butterflies are separated. By 2 power m minus 1. Samples. Next, step 6. Here the step 6 is complex number of multiplications. Complex number of multiplications. The formula for the complex number of multiplications in FFT, that is n by 2 log n base 2. We know that value of n, that is here the value of n is 2. Okay, by substituting that, what we get, 2 by 2 log 2 base 2, 1 into log 2 base 2. So log a base a value 1, 1 into 1, 1. So the complex number of multiplications are 1. Likewise, step 7. The complex number of additions. Formula to find out the complex number of additions are n log n base 2, 2 log 2 base 2, that is equal to 2. So 2 number of complex additions. Step 8. Trivial factor calculation. Factor calculation. So the formula to find out the trivial factor, that is k is equal to n into t by 2 power m, where small m is a stage index. So how many number of stages for a given problem? In a butterfly we have only one stage. So for the first stage, t value is equal to 0. For first stage, t is equal to 0 and m is equal, small m value is equal to 1. We know that the value of n is equal to, by substituting that, 2 of 0 by 2 power 1, 0 by 2, which is equal to 0. So k value is equal to 0. step 9. Here the step 9 is, what is the step 9? The number of sets of butterflies in each stage. The number of sets of butterflies in each stage. How we are going to find out the number of sets of butterflies in each stage? By using the formula 2 power capital M minus small m, where the capital M is number of stages and small m is stage index. So for a given problem, the number of stages, or how many number of stages? One stage. What about stage index? Stage index value, small m value is also 1. By substituting those two, 1 minus 1, 2 power 0, which is equal to 1. That is the number of sets of butterflies in each stage. That is 1. Next is step 9. So these steps for length n is equal to 2. If we will take a length n is equal to 4, automatically these values will change. Formulas are same, but by substituting that stage index value on the number of stages, we will get different values. Okay, so here the step 9 is exponent refit factor, ERF. Here exponent refit factor is also find out by using the formula 2 power capital M minus small m, that is equal to 2 power 1 minus 1, that is 2 power 0, which is equal to 1. Okay, now let us draw the butterfly diagram by using these 10 process steps. So what is given? X of n input sequence is given 1, 2. From the second step, with reverse ladder also same, that is x of 0 and x of 1. What is the value of x of 0 from the given problem? X of 0 value is 1 and x of 1 value 2. Let us substitute those two values here and let us draw the butterfly diagram. How many number of stages? Only one stage. For one stage we are going to draw the butterfly, and for each stage how many number of butterflies we have? For the stage we have only single butterfly. So upper line is multiplied by 1 and the lower line is multiplied by minus 1. And also according to the 8th step twiddle factor, W suffix 2 power 0. We know that a generalized formula for the twiddle factor, W suffix n power k, which is equal to e to the power of minus j 2 pi n 2 pi k, 2 pi small k by capital N. Now let us substitute k value is equal to 0. W suffix n power 0 is equal to e power minus j 2 pi of 0 by capital N, that is equal to e power 0, which is equal to 1. So W suffix 2 power 0 value is 1. Now let us calculate the value at this point. So at this point, from this direction we will get 1 into 1, 1, and from this line what we will get, 2 ones are 2, that is 1 plus 2, which is equal to 3. And here from this direction we will get 1, through this path we will get 1, and through this path we will get 2 ones are 2, 2 minus 1s are minus 2, that is 1 minus 2, which is equal to minus 1. So it is capital X of 0 and this one is capital X of 1. Therefore capital X of small k is equal to 3 comma minus 1. In this way we are going to find out DFT for a given sequence x of n by using DIT-FFT algorithm. Thank you.